Alrighty. And we're live. Fantastic. Well, welcome everybody. Thanks for joining us. My name is Alex Josh, and I'm a product manager for VMware Cloud and AWS.
My name is Ahmad Yunus. I'm a staff technical marketing architect for VMware Cloud and AWS.
So today we're going to be talking about the VMware Cloud offering. There's a lot of material here. We're going to go into some detail. We will be talking about what the product is, but this is not a 100-level session, so hopefully you've already heard about it a little bit. If you haven't heard about the product, newsflash, we have a partnership between AWS and VMware. Who didn't know that? Everybody? Okay, good. All right, good. So we're in the right room. Fantastic. So VMware Cloud and AWS was developed jointly between VMware and AWS. And what we like to say, it was kind of like a 60-40 venture. About 60% of the engineering was on the VMware side, about 40% on the AWS side. This product really could not exist without the two teams working together, right? VMware literally could not have produced this product on our own. And so it's been a fantastic experience. I've been on this project for about 3.5 years. When I started, it was a PowerPoint and some crazy wild-eyed people in a room. And now we have a running product, and we've been in market for about 1.5 years now. So what we're going to do today is we're going to tell you a little story. This is a play in 3 acts. There's a good guy. There's a bad guy. There's some excitement. There's some mystery. And there's possibility for failure. So what else could you possibly want? So first act, when the hero makes the SCDC. That's me. OK, here we go. So the most important thing to know about VMware Cloud AWS is that it's a full VMware stack running in the AWS data center. We get a lot of questions about this because it's kind of not obvious about what we're trying to do here. We're not running a nested hypervisor environment, right? We're not adding to the existing EC2 hypervisors. That's not what's happening here. What we're doing is we're creating an end-to-end VMware experience on top of AWS infrastructure. And the reason why this works is because we're consuming the bare metal infrastructure that AWS provides to us, right? So the .metal infrastructure doesn't have a hypervisor. And that allows us to introduce ESXi, which is our operating system. It's our hypervisor. And then put on top of that a VMware management stack. So when I say it's a very closely coupled joint partnership, you really don't get any closer than my hypervisor, your hardware, right? It doesn't get closer than that. And so what we do is we take ESXi, we put it on bare metal hardware. We then use vCenter to manage those ESXi hosts. And then we install vSAN and NSX. And so you have a complete environment, which we refer to as an SDDC, right? And that SDDC lives in a single dedicated VPC, belongs to you, right? So this is a protected environment. It's designed for private workloads. And then because we're running the same bits as we run on-premise, that allows us to do things like hybrid link mode, where you can literally pick a VM up and vMotion it from on-prem to the cloud and back again. And we're going to show you how to do that today. At the same time, because we're living inside of that AWS data center, all of the things that AWS does so well are all there for you. So things like S3, things like RDS, things like Redshift, they're all there, they're all running, and you can consume them natively over low latency, high bandwidth connections, right? And so you kind of have this melding of the two worlds. I spent a lot of my time talking to vSphere administrators and explaining to them what AWS is, right? So this crowd is probably a little different, right? So hopefully most of you are familiar with AWS. I don't have to have that conversation. But maybe you're not so familiar with vSphere. By the way, how many of you have used vSphere before? Oh, most of you. Fantastic. OK, that's great. So we won't spend a lot of time talking about what vSphere is then. So because we sit inside the AWS data center, we're consuming their infrastructure. And what that means is we run inside of AWS regions. So we are currently running in Oregon, Virginia, London, Frankfurt, Sydney. We just recently launched Tokyo, Ireland, Northern California, Ohio, and GovCloud, which actually got announced today. Right, there you go. So this is very latest stuff. And we're working on additional regions here, places like Singapore and Mumbai. The top-level agreement between the two organizations is that we will be supporting all AWS regions worldwide, right? So that's the strategy statement. And this slide is just kind of walking you through the implementation details about how we go about that, right? As you can imagine, there's a lot of work to be done to make sure that these regions are ready to accept these new workloads. Do I say my cloud joke now?
Sure.
Sure, yeah, okay. So we always say in our team, there is no cloud, right? There's just somebody else's infrastructure team. So literally what's happening is that the infrastructure we run on is very specialized. So there's an immense amount of work within the AWS facilities to make sure that all works smoothly, right? And that's the great thing about the partnership, is you have this team that really knows how to run data centers amazingly well, as I'm sure you all know, because you consume these services already. And what happens is we get to take advantage of that infrastructure. We get to live within that data center. We don't have to do anything special or different. So when that infrastructure comes up globally, we're able to consume it. So there's really 4 big topic areas which we tend to talk about in this product. It's about data center extension. That is to say, I currently have a data center that's running out of gas, right? I've got no more power or no more cooling or other reasons why I need more capacity, but I can't get it. This is probably the fastest way to take an existing virtualized data center and extend it a bit, right? Because you can literally bring up a new SDDC in an hour or so. And we're going to show you how to do that in a minute. Similarly, if you think about a disaster recovery situation, what a lot of customers traditionally have done is they've maintained a secondary or tertiary data center whose only job is to be ready in case of emergency. Well, for those of you that have ever done that, you know it's not a lot of fun, right? Because you have to go there and you have to keep it updated, you have to do patches, it's never on the right version. But it doesn't really provide a lot of value to your organization because it's not running anything, right? So having a secondary or tertiary data center sitting there in the cloud ready to go can make a lot of sense, right? So we do that for a lot of customers. The third thing, which is what we're going to spend the bulk of our time today talking about, is cloud migration, right? So we have a lot of customers who are in this mode where they say, look, I have this data center that's running out of lease time. I need to get out of there for some reason. It's running legacy hardware, and I just want to exit that facility completely, right? Can you help us do that? And what we're going to do today is we're going to walk you through the process of how you would go about that, right? So from soup to nuts, we're going to talk about creating the SDDC, migrating to it, and then managing it. So that's really the theme of the talk today, is how do I go from data center running on-prem with vSphere today to no data center on-prem at all, 6 weeks, 6 months from now. Obviously, next generation apps comes up a lot as well. We see a lot of customers that are doing things like hybrid apps. So the most interesting one I saw recently, I was at a customer site it wasn't last week because I was off last week, but the week before, where they had a very traditional legacy 3-tiered application that had a database, an Oracle database. But what they really wanted to do is they wanted to do ETL down into Redshift, right? And so they had a couple of choices about how they would do that, but it wasn't really working out for them, right? Because this is a running app. They couldn't just pick it up and move it easily to EC2. They weren't ready to shift to RDS either, but they really wanted to use Redshift. Well, so what they did is they just took the Oracle VMs, migrated them up into VMC, and then they ran their ETL job locally right into Redshift, right? So it cut their ETL time down by a factor of 10. So those kinds of things are very interesting, where you have these kind of hybrid applications that are taking parts that are running on-prem, parts that are cloud parses. Maybe you're taking a couple PaaS services out of AWS Native, and you put that all together into a single application, right? So really interesting use cases there. So just some facts and figures. So VMC has the ability to scale vertically and horizontally. We start with a 3-node i3 cluster. That's the smallest cluster we support right now for production workloads. So that's about 108 cores, 1.5 terabytes of RAM. And then we scale up to 10 clusters. So that's 15,000 cores and 243,000 terabytes of RAM. That's a lot, right? So net, I think we probably scale just pretty much the largest workloads that you folks are running in here. By the way, for those of you that have workloads that won't fit into this, please see me after the talk, right? I'm sure we can help you out. Also, same thing with storage. So in the original product, if you've seen the product before, we were only consuming the local storage that was in the i3 node. And so what you see here is the difference between a 4-node versus a 32-node cluster, right? So we go from 30T all the way up to 320T. We're going to talk about this in a few minutes, but there's other options now around consuming EBS native storage on the R5 platform. We'll get into that in a minute. And actually, we have a demo of that coming up in just a minute. But anyway, the net is, again, it's all about range of capacity, range of storage. Now, one thing you'll notice that I don't talk about like here is, well, what happens if I want to just buy like one VM, right? I have one VM, and I want to buy one VM. Then this product's probably not for you, right? That's not our intent here, right? What we're doing is we're creating a wholesale infrastructure product that's designed to be sold to enterprises or corporations, organizations that need that type of enterprise workload support, right? That's really what we're doing here. And that's why the current minimum size for an SDDC is 3 physical nodes, right? So if you're running an entire data center, 3 nodes is a relatively small buy-in, right? But if you want one VM, that's probably a little bit overkill. So it's just important to remember what we're trying to do here, right? We're trying to recreate an enterprise-grade, enterprise-scale environment to run your Tier 1 workloads. And from that perspective, then it kind of makes sense to see why we built it that way. We're sitting on top of vSAN, as I mentioned. And so what that means is that we stripe all of our workloads across multiple disks. This goes back to the theory of being an enterprise-class platform, right? So enterprise applications are assuming that the infrastructure is stable and the infrastructure won't lose their data. You can write applications that don't require that, but this infrastructure is designed for applications that do require that. So we use vSAN in that way. And what it allows you to do is, through policy management, it allows you to control how much redundancy you have in your infrastructure. And when I say redundancy, what I mean is the ability to withstand failure, physical failure, right? So you can lose an entire host, everything keeps running. You can lose an entire AZ, everything keeps running, right? Now, naturally, being redundant across an entire AZ is expensive because you have to mirror data onto a foreign AZ. Maybe your workload needs that, maybe it doesn't. The point is that you can configure that policy on a per object basis, very granular, right? So for example, if a VM is running the cafeteria lunch menu, maybe you don't have 14 replicas of that thing. Maybe it's not necessary, right? On the other hand, if it's running your SAP payroll system, maybe you want to have a couple replicas of that. And so what you do is when you configure the VMs, you tell us how much redundancy, how much performance, how much you need this particular application to have, and then we implement that redundancy for you. It's all built into the platform. It all just works automatically. So you set the requirements, you tell us what to do, and then we implement them. The other thing that we're very careful to do is we want to make sure that our clusters are completely automated, right? So for those of you that are vSphere administrators, you're probably used to doing a lot of this stuff by hand, right? You probably configure your own clusters. You probably even configure your own disks, right? You may do a lot of this kind of work by hand. What you're going to find that's very different about VMC is that we do all this work for you. So it's really important for us to make sure that we can guarantee that the system is up and running and is stable all the time. And so the way we do that is we do that by managing the configuration centrally. All SDDCs globally are configured exactly the same way. Now, again, for those of you that are vSphere administrators, you might say, well, wait a minute, Alex. What I really want to do is I want to have this custom configuration. I want to have this VIB on here. I want to have this special network. I want to do this. I want to have... So hang on, right? We're running a service, and we are responsible for operations, and we are responsible for uptime. So it's kind of this give-get situation where if you want us to be responsible for keeping the cluster up and running, you have to give up a little bit of control that you normally would have on-prem. Again, not necessarily what everybody wants to do, but if you want to have a service, like a dial tone, that's always there for you, you don't have to think about it, you don't have to manage it, then the way you get that is by doing something like this, where you give up a little bit of control and you allow me to manage that for you, and now uptime is my problem, right? So that's the goal here. So what we do is we make sure that those clusters are always configured optimally all the time. So if we get to a situation where the cluster needs to add hosts or needs to add an additional cluster or add additional space, this is all handled for you automatically in the background, right? So you can go in with a very simple UI. You can say add a host, right? And then you create these hosts, and then we then build the host, put vSAN on it, connect it to the correct networks. And this whole how happens relatively automatically with a couple of clicks or an API call. Similarly, if there's a problem, so let's say we have a vSAN cluster. So we have, in this case, we have a 9-node cluster. Let's say one of those hosts is having a problem, right? Let's say it fails completely as a hardware failure. Not unknown, not uncommon. What happens on the backside is that we're always watching, we're aware of the status and the health of the system. We will take remedial action on your behalf. And again, this all happens automatically. So when the fault is detected, we immediately add a new host to the cluster. Now, this is something probably that doesn't make a lot of sense to you if you're a vSphere administrator, right? In the vSphere world, on-prem, if you have a failed host, what do? You have a failed host on-prem, what do? You fix it. Yeah, obviously, you fix it, right? If it's a bad power supply, you get another power supply, right? Well, we're in the cloud, right? We don't fix things. These aren't pets. They're cattle. So in the cloud world, if something breaks, what do? You shoot it in the head, right? So in this case, what we do is we get rid of that host. So we introduce a new host. We automatically provision it into the cluster, right? And that's what these arrows are trying to indicate, that we move the data onto that new host, right? And then when that work is complete, the failed host is automatically removed. Now, again, this is all happening automatically. You may not be aware that this has even occurred, right? Unless you're watching very carefully. In fact, I had a customer the other day where they'd been on the product for about 9 months, and they said, yeah, it's amazing. We've never had a host failure on the system. Like, really? You have 30 hosts. You've never had a host failure? No, not one. Actually, you had 3 last week. What? Yeah, I had 3 last week. Bad week. They didn't know. They hadn't noticed, right? But that's good. That's exactly what we want, right? We want to make sure that any infrastructure hiccups or problems or irregularities are completely invisible or hidden, right? Because we can vMotion workloads, because we can use DRS and all the normal vSphere features, the workloads may or may not be aware this has occurred. Now, obviously, if you have a VM running on a host and the host just completely dies, then yes, that VM will go offline, right? You'll get an HA restart event, just like you would see on-prem, and we'll restart it on one of the surviving hosts. So yeah, you could see a VM go offline for a few minutes while it reboots, but the net is the infrastructure is still there. It's still stable, there's no data loss, and then the failed host is replaced, so now you're back up to the same capacity you had before. Similarly, on the networking side, we have a very, very rigid definition of how the management network should work. The compute networks, the networks that the guests, the VMs talk to, those are totally up to you, right? You can have a lot, you can have a few, as many as you want. Routing architecture is up to you. Don't worry about that. But on the management side, it's very strict, and they're under our control. Again, same reason, right? If you decided to turn off the vMotion network, for example, well, that would have a pretty negative outcome to the health of your cluster, so we don't want to allow that, so we don't let you do that. Similarly, if you decide to change the IP address of vCenter, and suddenly we couldn't talk to it, that'd be pretty bad too, right? So none of those things are allowed. You can see that infrastructure. You have read-only access to vCenter, but you can't modify it. You can't change it, right? Which is the critical difference between what you're used to on-premise and what we're doing here in VMC land. So what we do is we build up these management infrastructure. We have a dedicated edge device we call the MGW, right, which is right there on the screen on the left side. And then we have a CGW, a compute gateway, which is on the right side there. And so those 2 objects are the way you talk to the infrastructure. You'll notice that there's no common point of failure between the compute networks and the management networks. Why is that? Well, because that's VMware's best practice, right? You want your management traffic isolated from your workload traffic. And instead of asking you if it's okay for us to implement best practices, we just go and do it, right? And we don't ask you, we just go do it. So these management networks are built in such a way that you're always compliant with VMware best practices. We actually had a really interesting conversation with our support organization the other day, because they actually have a service where they go on site and they help customers become compliant with VMware best practices. And so they came to us and they say, hey, we want to deliver this best practice tool to VMware Cloud and AWS customers. How do we do that? And I was like, well, I think they'll always pass. Well, what do you mean? Can't they turn off this network? No. Can't they misconfigure their vMotion? No. Well, what happens if they don't patch? Well, no, we patch for them. Well, it was a very interesting conversation because we quickly came to the point that we realized that there's this whole series of tools that we've built for on-premise to help people remain compliant with best practice. And we just implemented those tools here in software. So it's just a very different way of thinking about things, a different way of running the environment, different way of operating it, right? The other interesting thing that here happens is that because we comply with these best practices, we are secure by default, right? So all the ports are off. All the IP addresses are off. Some people might not expect that, because on most on-premise environments, what you do is you start with everything on, and then you slowly turn ports off. But that's not best practice. Best practice is start with all ports off, and then turn them on one at a time, right? So it's kind of backwards. So there's a lot of these skills that some of us, myself included, have had to kind of relearn over the years. Imad's laughing at me because he knows I don't learn very quickly. Okay, so that's kind of the way the product works. So let's take a look at it. So Imad's going to be my driver here. So what we have here is we have the product. This is VMware Cloud and AWS. When you log in to the console, is what we call it, you see this interface, and you can see we have a running SDDC here. But we're going to go ahead and show you what it's like to make one, right? So if I wanted to start from scratch, what would I do, right? So the first decision I have to make is where do I want to deploy this thing, right? And as you can see, we have a nice list of options there, right, including GovCloud, which is this morning. Good job updating the demo environment, Imad. And then what I have to do is I have to pick, do I want to have a test SDDC that I'm using just for certification and testing that is not going to be permanent? In that case, I might want to use what's called a single host SDDC. So what we allow you to do is we allow you to make a very small SDDC that only has one host. But there is a caveat there, right? Because that's not a production quality SDDC, right? We can't do vMotions, we can't go to maintenance mode, we can't do all that kind of stuff. We limit the lifespan of that thing to 30 days. And at the end of that 30 days, you have a choice. You can upgrade it into a full production SDDC, or you can terminate it, right? So if you just want to do some testing, you just want to play around, go ahead and make a one node. It's fully functional, but it has a limited lifespan, right? That's not what we're going to do. We're going to go for a full multi-host, right, which is a real production SDDC. And what the hell, we'll go for stretch cluster too. How many of you have ever set up a Metro cluster environment on premise? A couple of you. Was that easy or hard? Don't be shy. It was hard, right? We're friends here. You can talk to me. Yeah, it was hard, right? It's not really easy setting up Metro clustered environments because you have to do things like infrastructure support, you have to do networking, sometimes you have to do fiber channel stretches, all kinds of weird things. In our case, Imad just configured this by clicking a checkbox, right? So by clicking that checkbox, what you're telling us to do is to take your workloads and stretch them across 2 AZs within a single region, right? A very powerful construct. Now, from an AWS perspective, what AWS will tell you is that the only way to get a guaranteed SLA is to make sure your workload runs in at least 2 AZs. Makes sense, right? Well, now I have to go change the way my application works, though, so that I'm AZ aware, right? Or you can check that checkbox. Once you check that checkbox, every VM in this SDDC is now fully protected, and if you lose an entire AZ, the VMs continue to run, right? So that's a huge deal if you think about it for production enterprise class applications.
Of course, this is the only time that you can configure stretch clusters. So if I uncheck the box and decide that I'm going to do a multi-host SDDC and later on decide, well, I wanted to stretch it across, I can't do it. I'm going to have to basically create a whole new SDDC and then start moving my workloads across. So just keep that in mind.
Yeah, excellent point. Thank you. We try to minimize the number of non-changeable decisions you make, but this is one of them, right? Stretched or not changeable. The other one, by the way, is the CIDR range of your management subnet. That's also not changeable. Almost everything else is, but those two things are not changeable. The second one, sorry, the question was, can you please repeat that? The second thing you cannot change post-deployment is the CIDR range, the IP address range of your management subnet. That cannot be changed post-deployment. So I give the SDDC a name. I say how many hosts I want to start out with, which, by the way, can be changed later. You can go up or down later. That one's not one of them. And then what you can see is when you pick the different sizes, it tells you how much capacity we're going to be giving you, right? We're going to do that, we're going to do that, and we're going to put this on AWS. And we're going to say next. And so now what it's asking you is it's asking you to link to an existing AWS account. Now this is probably the most confusing part of the entire setup experience. So I'm going to explain it really slowly, and I'm going to use little words. No, just kidding. The reason why this is so critical is because this is the mechanism that allows you to consume AWS native services, right? Because think about it. If you want to create an S3 bucket or an RDS instance or others, you can't create that in a VPC that I'm responsible for, right? Because then I'd have full access to all your data. You don't want that, right? You don't want me looking at your RDS tables. That doesn't make any sense. So it has to be someplace else. Well, where are you going to put it? Well, you're going to put it in a VPC that you control in an account that belongs to you. Makes sense, right? Well, wait a minute, but now I, VMware, need to be able to figure out how to talk to that thing somehow. How do I do that? I do it here. So what this is this is the account, the only account, that your VMware SDDC can talk to. And you set this here, and by doing this, you're basically delegating permission to me to talk to one and only one network that you own, but that I have access to. So this becomes the shared kind of a DMZ almost like thing, right? This is a thing that I have access to, you have access to. You put stuff in there, we can both see it. So think of this as like a VPC DMZ. That's a horrible analogy, isn't it? But you know what I mean, right? Hopefully some people are nodding. Okay, so it's not that bad. All right, so I pick the account. I pick the VPC, right, as I explained earlier. And then something really interesting happens is now it asks me to pick some subnets, right? Because remember, I said I'm only one network. But then when it comes up and it says, well, wait a minute. First of all, it says pick 2. Why is it asking me to pick 2? Any ideas? VMware people can't answer. Stretched cluster. Somebody in the back says stretched cluster. Yes, exactly. Because now the hosts are actually living in 2 AZs. And a subnet is, as we all know, because we passed the exam, is an AZ construct, isn't it? So we have to have 2 of them. So what we're doing is the hosts in AZ1 get connected to subnet 1. The hosts in AZ2 get connected to subnet 2, right? And that's why this works. If I was using a single AZ setup, a not stretched, then I would have just picked 1. The other interesting side effect of this action is notice the parentheses there. It says that I'm going into US East 1C and US East 1B, or 2B, right? So we're also making a placement decision right now. We're deciding which AZs to put the infrastructure into, which, by the way, is exactly the way EC2 works, right? When you pick the subnet for your EC2 VM, that decides which AZ you're going into. Same here. Okay. And then the last thing you do, and this is the other non-changeable, right? It's right here. You give me a CIDR range where all my management VMs lived. And that can't be changed. And the reason is because VC and all those kinds of things are there. And if you change them, we could lose connectivity to the VPC. So we don't want to allow that, right? So we set that here. Now, we're not actually going to create an SDDC right now. I know you're all super disappointed because you really wanted to see it click OK. But don't worry. This is a cooking show. We baked a cake earlier. Iman's a great cook.
He won't let me hit deploy SDDC.
So that operation, by the way, if he had clicked OK, takes about an hour, right? Hour and a half. So it's not immediate. But if you've ever deployed an entire data center on-prem before, it takes a little longer than an hour. Once you're done, what you get is vSphere, right? Amazingly similar, actually. If you've run this before on-prem, it should look super familiar because it's vSphere, right? It's the same code, the same bits, right? We're a little bit ahead of the on-premise release in terms of versioning, right? But the bits are fundamentally the same bits. If you open up the cluster 1, and click on one of the hosts there, you'll see that I'm running a i3, Amazon EC2 i3 Metal, right? So I'm obviously running an Amazon, right? That's not a HP server. But it's running in their infrastructure, but it's running vSphere. Also, you'll notice that I have 2 clusters here, right? So the clusters can have different types of hosts. If I click on the second cluster, you'll see, hey, it's a different host. It's a R5 Metal host, right? So at the moment, those are the 2 host types that we support, i3 and R5. i3, as I mentioned earlier, has its own locally attached storage, so we're using the SSDs that come in i3. It's 14 T of disk. What's interesting about R5s, though, is they don't have any local disk. So what we decided to do was to use EBS instead. So when you provision an R5 cluster, you tell us how much EBS storage you wish to consume from 15 to 35 T, right? So in this case, what you can see, if you click over to the data center view, you'll see that the R5 data store is way bigger than the i3 data store. And that's because the i3 instances have 10T each, and the R5 instances have 35T each, right? Now, that just happens to be the way I chose to configure this. You could change that, but that's what's going on here, right? All right. Makes sense? Great.
So the other thing kind of to note is the management resource pool. That's where all the management components are deployed. So we have our H5 client, as Alex was talking about earlier, so you should be used to that with vSphere. But here, we'll deploy vCenter, we'll deploy NSX, we'll deploy HCX. All the management components are deployed into the management resource pool. You do not have access to the management resource pool. The only thing you have access to is the compute resource pool. And that's because we're giving you time back to consume and have that focus only for the workloads, and we will take care of managing the infrastructure. So all the patching and the updates that you typically have to do in a vSphere on-premises environment, we will handle. So no more having to worry about updating vCenter, updating the hosts, even updating NSX. We handle all that for you, and what we wind up doing is we'll send you a notification of a maintenance window. You select the maintenance window, and we'll take care of all the patching, providing notifications along the way.
Fantastic.
The other thing really quick, sorry,
Sorry, I pushed the wrong button. Go ahead.
is once you come in here, you have kind of a few details. So here we have a 3-host SDDC, but what I want to kind of highlight here is we have an add-ons tab. So when Alex was talking about disaster recovery, typically on premises, you have to configure Site Recovery Manager, SRM. Well, here, it's just an add-on. I can go in, I can enable it, and we'll go ahead and deploy it within VMware Cloud on AWS, and it will provide you a link to the bits to deploy it on premises, and now you can link together and have a DR site within the cloud. The other thing is we have what's called Developer Center. And you come in here, we're API first, of course, so we have an API Explorer. So if you're familiar with what we did with the vCenter Server Appliance, we have an API Explorer. Here we have the same thing. The only good thing here is we actually provide information. So if I go in here and look up my SDDC, it's actually going to give me my SDDC name. I don't have to look it up. And now I can actually go through and do some testing or whatever. I can do like a post or whatever. So it's kind of dangerous at the same time, right?
Yeah, by the way, if you use the API Explorer, keep in mind, it's live, okay? I had somebody want to find out how the delete SDDC API worked. Turns out it works great.
Actually, we have a guy on our team that's deleted our SDDs.
Yeah, so just be aware that the API is completely live. If you have a dev team that wants to fool around and have a safe sandbox, more than happy to provide you with a test in org, right, that's safe where they won't break things. So just use caution playing with live.
Right, so as you can see here, like if I want to get my org ID, I find it over here, right? And then we also have sample codes, we have our SDKs, and then you're able to download DCLI or PowerCLI as well.
Fantastic. So I'm going to speed up a little bit because I blabbed a little bit too much. All right, so remember I said there's 3 acts. Here we go. Act 2, this is when the villain shows up. Okay, here we go. So we said we're going to go on this journey, and we're going to go on this magical journey to cloud, right? We're going to move our whole data center. And, it's interesting when you talk about these things because, when you plan something like this, you have these ideas in your head about what way things are going to go, right? So you're like, we're going to shut this data center down, and we're going to go to cloud. And you know what? It's going to be amazing. It's going to be a rocket ship ride. It's going to be a blast off into space, right? And then you tell your internal customers, hey, by the way, we're going to the cloud. And they're like, yeah, like 2001 Space Odyssey. We're going to have all this kind of cool stuff. It's going to be amazing, and it's going to be great. And like, whoa, I didn't say that. I just said let's not get carried away. And then and then it's like, okay, let's go do it. And it's like, wait, I have to make the spaceship myself? Oh, man. Maybe this is not such a good idea. So these things, they creep up on you, right? And so, what we're trying to do is we're trying to provide a way to get this done easily, right? And so that you can do this. And we've done this hundreds and hundreds of times now. And so we have a lot of experience about the way this works. And Ahmad's going to kind of walk you through that a little bit.
Sure, thanks. So here we have our on-premises data center. You can see we have vSphere, we have some sort of networking, so it could be a standard virtual switch or a distributed virtual switch. We have some sort of storage, as well as virtual machines. Of course, we have vCenter. On the VMware Cloud on AWS side, as you can see, we also have vSphere, but this time for the networking, we have NSX. And one thing that comes up a lot is, well, if you have NSX on the VMware Cloud on AWS side, do I need NSX on-prem? And the answer is no, right? We're able to take care and handle all the networking, and you'll see here stretching and all that using layer 2 stretch within VMware Cloud on AWS within the console, or we can use something called HCX to do so. The other thing you'll notice here is we have vSAN for the storage. So again, you don't have to have vSAN on-prem to be able to leverage VMware Cloud on AWS. The other thing to notice is we have content library and hybrid link mode. Now, typically you have ISOs, you have scripts, you have content that you leverage on your day-to-day, templates, all that you don't want to have to copy over or reinvent the wheel, right? So we'll leverage content library to keep that content in sync from on-premises to VMware Cloud on AWS. Now, one thing we've done within vSphere 6.7 Update 1 is now content library is aware of native VMTX templates. So now we can actually leverage content library for the native VMTX templates. The only thing here is we can't replicate those templates because it's still a vCenter construct, but we are working towards that. Anything else we can actually replicate across between on-premises and VMware Cloud on AWS. Then we have hybrid link mode. Now, hybrid link mode gives us that capability to not only get a single management view, but we have two different SSO domains that we are bringing together. So we have vSphere.local on premises, and then we have VMC.local within VMware Cloud on AWS. And we're able to provide that link to manage both sides, but at the same time, we retain separation of permissions. And we'll talk about that here a little bit later. So we can move our VMs, from on-premises to VMware Cloud AWS, but we can also move them back. We are not bound. So once we move, it's bidirectional. You can move it as many times as you want. Just remember, it's always free to go to the cloud, but there are charges coming back down. As far as options for workload mobility, we have something called Hybrid Cloud Extension, or HCX. I'll cover that here in a little bit. We have Live Migration, or vMotion, that you should be familiar with. We also have Cold Migration. Content library we've kind of covered. But then there's Enhanced vMotion capabilities, or EVC, that you need to be aware of, because if you move a virtual machine, let's say from on-premises to VMware Cloud on AWS, and you want to move it back, well, the processor types are different, and that may require downtime, and you need to be aware of that as you're moving VMs back and forth. So, Hybrid Cloud Extension. This is a functionality that's natively built into VMware Cloud on AWS, but it's also available for the on-premises to on-premises use case as well. This is the all-inclusive Swiss Army knife of workload mobility. And why do I say that? It's because it's got everything natively built in. Typically, you'd need several different products to glue all together to make this happen. HCX has everything built in. So here, as you can see, we have already WAN optimization, we have dedupe, we have compression, all natively built in. We can actually, from within HCX, stretch our network from on-premises to VMware Cloud on AWS, right? We support versions all the way back to vSphere 5.0, all the way to the current version of 6.7. We support bidirectional migrations, as well as we'll let you leverage your internet connection. So minimum requirement is 100 megabits per second, or you can use a direct connect as well. Doesn't matter. So the other thing we can also do here is we can schedule these migrations, because the last thing you want to do is sit here and highlight 100 VMs and watch the grass grow, right? So here we can actually schedule those, come back, and watch our data center completely evacuate in no time, right? Depending on, of course, the connectivity. So here we can actually bulk migrate 100 VMs, 1,000 VMs, right? And it's pretty simple because everything is all built in. We establish a secure connection from on-premises to our VMware Cloud on AWS compute gateway. So it's Suite B encryption is happening there, all native to the solution. And again, it's free for VMware Cloud on AWS.
Yeah, can't really overstate the capability here. I mean, we had a customer that wanted to close a data center. They had 1,500 VMs in it. Their estimate was 6 to 9 months. We literally did it over a weekend. Yes, there was 4 weeks of planning to get ready for that weekend, right? Don't get me wrong. But once we decided, once we hit go, right, the actual migration time was very, very, very fast. This is the fastest way to move VMs into the cloud, full stop, right? There is no faster way, there's no way.
No.
So this is an incredible tool. It was developed by a team within VMware, so fantastic job here. Not my team, but a very, 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 very good work there.
Okay, so earlier I showed you that you can go into the add-ons tab, and now we can enable Site Recovery Manager. Well, HCX is the same way. It's just that simple. I go into add-ons tab, I click activate, and once I click activate, it's automatically going to go out and deploy the components that are needed. So the HCX Manager, the WAN optimization, all that is deployed for you. And then after that's done, you'll get a link to download the bits for on-prem, because again, we got to start doing some pairing between on-premises and VMware Cloud on AWS. And I'll show you that here shortly within a demo. The other thing to keep in mind is enhanced vMotion capability. So here, it's all native to HCX. So we can actually move VMs to different processor types, right? So within VMware Cloud on AWS or back to on-premises, and the VM doesn't need to be powered off. It will actually inherit the chipset that you're living on once the VM is rebooted. So you can move them back and forth seamlessly, whereas if you had to do this, let's say native on vSphere, you can't do that, right? So we now have that capability native within HCX. By the way, in vSphere 6.7, we have a notion of per VM EVC. So now we can enable EVC at a per VM level, and now those VMs can move between different processor families. So native to HCX, you have cold migration, right? So it requires downtime. We have live migration or vMotion, which there's no downtime. We have the notion of bulk migration, which is low downtime, because what winds up happening is with bulk migration, we wind up having to do a cutover. So we replicate the virtual machines from on-premises to VMware Cloud AWS, and then at one point, we just cut over. So we'll shut down the on-premises virtual machines, and now they're live within VMware Cloud on AWS. So you kind of almost have an easy way to roll back as well. So that's where the low downtime comes into play. But we have two other options. The first one is in Tech Preview, and that's Cloud Motion with vSphere replication. And that provides no downtime whatsoever. So here what we're doing is we're using vSphere replication to replicate the VMDKs, so the virtual machine disks, from on-premises to VMware Cloud on AWS. And then what we'll do is we'll use vMotion to do the cutover of the delta sync of data, and there's no downtime involved whatsoever. The other one, should I share this one?
Are we allowed to talk about that?
I'm going to talk about it.
All right.
All right.
Let's do it. Let's do it.
All right.
Let's do it, right? Yeah, they want to hear about it.
All right. So in development now is Cloud Motion with AWS Snowball, which again is zero downtime, and we're leveraging an AWS Snowball now to basically seed the data like you would, send off the Snowball. Now from an S3 bucket, we can pull down the data, and again, involves zero downtime. I have a couple of demos here that we'll go through.
Yeah, I think we need to get going with the demo.
Yep.
Okay.
All right, so here, just real quick, because we're running out of time, is the steps for the Cloud Motion with vSphere application. We talked about it earlier, right? So I'm going to select some virtual machines. I'm going to schedule the migration. And then after that, we're going to replicate the virtual machines to VMware Cloud AWS. And if we want to, we can actually schedule the cutover, or we can just let the cutover happen. So this is really good to meet your SLAs. And then once that's done, the virtual machines are now live within VMware Cloud on AWS. With the AWS Snowball option, of course, we still have to order a Snowball, but the steps are really similar except for, let's say, step number 4, where once we get the Snowball shipped to AWS, of course, we're going to transfer data to an S3 bucket, and now the data is replicated to VMware Cloud on AWS. We'll use vMotion to sync the deltas, and now those virtual machines are now live.
Yeah, let me
Yep.
jump ahead.
So we've already covered hybrid link mode, but one thing I want to talk about here real quick is you can see, like, on premises I have 3 vCenters, and within VMware Cloud on AWS I have one virtual center. And here I can manage all 4 vCenters from within one UI, but again, I retain 2 separate permission models, right? So here I'm logged in with my AD credentials, but I'm able to manage all 3, but I'm also limited to what I can do within VMware Cloud on AWS. So on premises, I'm full admin. In VMware Cloud on AWS, I can only manage my workloads. Another thing that's in preview mode is what's called the vCenter Cloud Gateway. Now the difference here is typically with hybrid link mode, I would have to enable it on the cloud side down. So I would have to log into the cloud side with my Active Directory credentials to manage. Now we'll deploy a gateway appliance in your on-premises environment, and we're able to now manage from your on-premises to the cloud. The last thing that I want to talk about real quick before I go to the demo is we can actually independently use something like PowerCLI and use the move VM commandlet to actually do this without leveraging hybrid link mode or anything like that. So we do have REST APIs available. We have integration with Terraform and CloudFormation, so definitely check those out. All right. So here I'm in my H5 client, and you can see I have an HCX plugin. A couple of things I want to highlight here. So what you'll notice here is I already have a network extension. It says one network extension. I can do up to, whatever I want, right? I can extend as many networks as I need to, depending on the VLANs or networks that the virtual machines are on. The other thing you'll notice is that I have an on-premises vCenter server that is site paired with a VMware Cloud on AWS SDDC. Again, I can have multiple on-premises vCenters paired to one SDDC or paired to different SDDCs. So if I have different workloads spread across the world, I can actually bring them all to one SDDC if I need to. So now we're going to go in and we're actually going to do a migration. And with the migration, it's just going in, hitting migrate virtual machines, and we're going to start to pair where we're going to move these things to. So here I have a prod resource pool folder, and I'm going to go into the global view of HCX, and I'm going to select the workloads folder, because again, my destination is VMware Cloud on AWS, so that's the only folder I have access to. I'm going to select the compute resource pool, and then I'm going to select the workload data store. Now, in this demo, I have CloudMotion with vSphere replication, right? So here, this is where we're going to select 0 downtime for our migrations. I'm going to go down and schedule my failover. So here, I want, after the replication to happen, I want that vMotion to occur within this window, right? So this is pretty cool because typically you can't really schedule a migration. Now you can schedule the cutover whenever you need to meet your SLAs. So once I'm scheduled, I'm going to go in and select my virtual machines. In this case, I'm selecting 100. And I'm going to click Next, and it's going to go through and make sure that everything is validate and meets the requirements. Once that's done, it's going to go out and start to prepare the virtual machines for the replication piece. Now, I'm going to pause here for a second, and I'm going to go to a different demo. And in this demo, I'm actually doing CloudMotion with AWS Snowball. And it's the same thing, except here, I only had access to one virtual machine that I was able to move just because it was in development. And now I'm going to hit finish. And now, as you can see, it says Snowball. I'm pinging the virtual machine to show you that, there's no smoke and mirrors. This virtual machine is actually still running as I am copying the data. No interruptions whatsoever.
Yeah. Now keep in mind what's going on here, right, is we have ordered the Snowball for the customer, right? The customer put it on-prem. We take a snapshot, put the data on the Snowball, send the Snowball back. AWS mounts it in S3. We bring it back from S3. We restore the snapshot in VMC, and then we basically vMotion to a snapshot. A lot of complex things that are happening there. The user experience that you see here, though, is very simple, right? The user experience is right-click, motion, off you go. But under the covers, there's a lot of complexity going on, right?
Right.
So just keep in mind that both times the workflow was exactly the same, but the transport was completely different, right? One was an inline transport over replication, over the wire, right? Internet, DX, whatever. The other one was offline transport via Snowball, right? So I just stopped the demo there because it wasn't really obvious how different those two were, right? So you might have missed that. But super important, right? So this is going to be a very big feature for us going forward in helping customers get out of environments with very low connectivity, right? Maybe high latency and others. We have a lot of customers that are highly distributed into small sites. It's quite difficult to bring workloads. If you have 40 terabytes, 100 terabytes, 1,000 terabytes of data, it's hard to get them out of there, right? So Snowball offers a very unique opportunity for us to migrate and do it very, very quickly, right? Sorry.
Oh, no worries. Due to the sake of time, we can talk about HCX after. So I'm going to switch back to.
All right. And of course, every story ends with, and they lived happily ever after, as every demo does. So, just a real quick discussion about day two operations, right? Because one of the things that people don't think about, they don't talk about, is day two, right? So we give you this thing, we run it, everything's fine, we leave. But that's not really the story here. The story is that you're going to be running this thing for years. And so it was designed to enhance your day two operations and make your day two operations easier. So one of those things that we put in the system was what we call Elastic DRS. So Elastic DRS is basically autoscaler, but for clusters. And the way it works is you give us a minimum and maximum cluster size, and then based on that minimum and maximum cluster size, we automatically configure the SDDC for you. We create the correct number of hosts. We will scale up. We will scale down. We'll handle that all automatically in the background. The add host operation, whether it's manual or EDRS, as I said, is completely automated, right? It takes about 10 to 15 minutes, right? Keep in mind that the scale up operation is a lot less expensive than the scale down operation, hopefully for obvious reasons. If you scale down, you need to evacuate the data and the host. That's not free. That takes some time. So if there's very little data, it's quick. But if there's a lot of data, it could take quite a while. So keep in mind, we do scale up and down, but scaling up is less expensive than scaling down. We talked about Stretch Cluster a little bit, but I just want to spend like 30 seconds, and I'm sorry, we're backing up into time, so I'm going to have to speed up here. Feel free, by the way, to come and ask us questions afterwards. We're happy to go into more depth. We also have a booth downstairs. Happy to talk about this in immense detail. But I just wanted to bring up, we did discuss how Stretch Clusters worked. I just wanted to show you a quick screenshot because it's not always obvious to people the way you configure this. The way you actually configure this is inside storage policy-based management, you actually configure an SPBM policy that says if you want to be stretched or not. So you can see up in the top there, it says, what does it actually say? It says site disaster tolerance. Sorry, I'm old and I wear glasses, so I can't read that. But right now it's set to 0. So what that means is that our data is only living on one AZ. And so the way you stretch across two AZs, and this is the default configuration, by the way, is you say, I want to have dual site mirroring. And now what the system does is it automatically stretches your data across the two. So literally, it's like 4 clicks of your mouse, and now you are protected against a complete AZ failure, right? Which is pretty crazy. Notice also on the far side there, there's a witness. The reason why the witness is there is to ensure that you don't have a split brain situation, right? And what I mean by that is if you have the two AZs and they lose communication between them, one of them has to win, right? One of them has to be the owner, and only one can win. And so we use the witness, the third-party witness, to make that decision, right? So I have an authoritative copy of the data. I can talk to the witness and I agree, that's a majority, I win, right? And if the other one who's isolated, he's like, well, I can't talk to the witness, I lose, so I'm going to lose, right? That way you don't have to worry about split brain and parallel writes and all the bad things that happen, right, when you have split brain syndrome. All right, so I bet you didn't think you were going to have an epilogue, did you? You are going to have an epilogue. So what's the moral of the story, right? The moral is it's about velocity, right? We want more space shuttle, less making things in your garage. It's been an amazing journey between us and AWS over the last 3 years, and there's a lot more to come, I can assure you. And in fact, we have some stuff going on, so there's things going on. Really, it would be great if you're interested in this product. Please do keep an eye on our roadmap. Our roadmap is completely public. This information is updated on a daily basis. Everything that I'm doing, well, not everything. Most of the things that I'm doing, hey, you got to have some secrets, right? Most of the things that we're doing are here on the roadmap.
And some of the stuff that you'll see within VMware Cloud AWS, it makes sense for it to translate to on-premises, right? But then there's some things that are only available for the cloud side. But this gives you kind of a hint in what may potentially be coming to the on-premises side.
So remember I said most things are on the roadmap? So there's one thing that wasn't on the roadmap, and that was announced this morning. So hopefully everybody was in the keynote this morning, and you saw the announcement of AWS Outposts. So we've been working with AWS on this Outpost project. The really exciting thing about Outposts is that because it uses the same core infrastructure as AWS uses, it allows us to redeliver the VMware Cloud and AWS experience on-prem, if you wish to consume it that way, which is super interesting, right? If you think about it, the ability to run exactly the same managed infrastructure on-prem and in the cloud is pretty unique, right? And maybe some customers really want that. So what we've said is, look, if a customer decides to buy Outpost, why couldn't you just run VMC on there, right? It's an AWS data center, sort of. It's a rack of an AWS data center. It's got all the same APIs. In effect, it becomes like a little private mini region, right? And so that's a really interesting target. It's like, well, why don't we just put vSphere there? So we put vSphere on there. Now you've got vSphere running there, and now you can move workloads around. You can consume that infrastructure. We do all the patching. We do all the management. It's that same fully managed experience. So all kinds of interesting possibilities. Now, this is a very new project. We're all super excited. I have to say we don't have an immense amount of detail here. We've just gotten started. But if you can think about it, there's a lot of potential here. So I just wanted to bring this up. This is a futures thing. We're working on this right now. And it's something you'll see next year. The intent here is that it will look a lot like what we've been talking about today, right? So in this experience, you'll simply go in here. You'll order an Outpost rack. We will use information from vSphere to tell you how to order it, right? So we'll go interrogate vSphere. We'll say, yeah, you actually need 6 servers or 10 servers or 20 servers or whatever. You'll go and order it. The thing will show up, right? It'll be delivered on site. And then it'll just appear as another SDDC exactly the way that the ones do in the AWS data center. So this is brand new. We just announced this morning, but it's very, very, very exciting. So with that, thank you all very much for your attention. We certainly appreciate it. Iman and I will be here after the session. More than happy to answer all your questions. And please do come by the booth, ask us questions, ask for a demo, or log into vmc.vmware.com and try it out for yourself. All right.